During an earthquake, you're first going to feel shaking back and forth. Then, the shaking is going to start to go up and down. And then comes the roll. Oh! In today's video, I answer questions about earthquakes as I go in search of them around the world. So where do I begin?
Well, there are no earthquakes without faults, or cracks in the Earth's crust, and faults are found all over the world. But most faults are found at plate boundaries, the place where tectonic plates, or pieces of the Earth's outermost layer, the crust, diverge, which means to pull apart, converge, which means to come together, and transform, going side by side. So I could go to California, where the famous San Andreas Fault Zone has resulted from the plate boundary between the Pacific and North American plates.
But if I really want to see an earthquake, I need to go to Japan.
And that's because Japan has 4 tectonic plates converging or coming together directly underneath it. These plates are crashing, subducting, resulting in earthquakes, volcanoes, and there are faults all over the place. Everything red is a fault. There's a fault here, and another one here, and another one there, and...
So here's my plan. I'm gonna walk around Japan for like a week. I'm gonna see if there's any earthquakes that happen. I hope that one happens. I hope it's not bad. I don't want anybody hurt, any buildings broken, but I'd like some stuff to get shaken up.
It was tough seeing the unbelievably beautiful places while searching for earthquakes, and meeting the unbelievably kind people, and learning about the fascinating culture, but I sacrificed for science. For better or worse, I didn't feel any earthquakes while I was in Japan, even though there's a tectonic plate boundary under the water directly in front of me. But still, I had to wonder, what would I feel if there were an earthquake?
So similar to me pushing on this table without it moving, as 2 tectonic plates attempt to move past one another, tension builds and builds and builds until there's a sudden release.
At that moment, a tremendous amount of energy leaves the focus or origin of the earthquake in the form of 3 different types of seismic waves. The first wave you'll feel, because it's the fastest, is the P wave, which is a longitudinal wave that moves by compressing and expanding the Earth as it goes through it, shaking things back and forth, startling but not the most dangerous. In second place in the seismic wave race is a transverse wave known in the seismic world as an S wave. A little bit slower than the P wave, it moves the Earth up and down as the energy passes by. More dangerous than the P wave, but still not the worst. And finally, slowest but most dangerous is the surface wave, a combination of the first 2 waves. It passes by in a rolling motion. These are building destroyers. For the full seismic wave dance, tune in at the end of the video.
Most people know that the size of an earthquake is measured on the Richter scale, but what you may not know is that the Richter scale is logarithmic.
And a 7 on the Richter scale isn't just a little bit bigger than a 6, it represents 32 times as much energy released from the earthquake. And an 8, that has 1,000 times as much energy as a 6. No thank you. And we measure the energy of these waves using a very sensitive tool called a seismometer. The amplitude or height of the waves give us its magnitude. And I will say this, if I have to experience an earthquake, I'd like it to be in Japan, because the Japanese make their buildings with special features to withstand earthquakes. But even better is to be outside.
On this very spot a few years ago, I was going for a hike when I started to feel a little seasick and heard some dogs barking in the neighborhoods nearby.
And then my brother called, freaking out because there was an earthquake shaking the house and knocking things off walls.
I didn't even notice anything happened.
So it turns out earthquakes aren't as dangerous as you might think. It's really just the buildings and structures we spend our time in that are the danger. And there aren't any more earthquakes now than there were in the past. There are just more people living in bigger cities near plate boundaries. Now, if earthquakes happen underground, how do we know where they started?
Remember how the 3 types of seismic waves travel at different speeds?
With my son as the P wave and I'm the S wave, we start at the same time. But as our distance from the start increases, so does the distance between us. You can see it on this graph. To go 2,000 kilometers, it takes a P wave about 3 minutes. It takes the S wave about 6 minutes. So if there's a 3-minute difference between when the 2 waves hit, the earthquake must be 2,000 kilometers away.
So let's say, using this method, you determine the earthquake happened 250 miles away from city A.
That could be anywhere on this circle, so you need to gather more data, and you find out the earthquake was 143 miles from city B. You draw another circle, and there are now 2 possible locations the earthquake could have happened, where the circles intersect. They're the only spots both 250 miles from city A and 143 miles from city B. To find the epicenter though, we need to draw a circle around city C. And there it is, triangulated from the seismic wave data. The good news is, earthquakes happen every day, all over the world, but most are too small to feel. unless you're a seismometer.
Earthquakes are a part of life on Earth, and the more we know about them, the better. So be careful out there, especially if you live in a fault zone. Take time to make a plan and get yourself prepared in case you experience a major earthquake. The Earth is a dynamic world.